So welcome to Serving Rasters with Geoserver. This is sort of part one of two of some webinars that I'm going to be doing on Geoserver. This one will focus on rasters, and then later on this month, I'll be mentioning that I'll be doing another one on serving vector data with Geoserver. So with that said, we're going to dive right in. Just a little bit about our company. Luna Geospatial specializes in three main areas. We do consulting and training, specialists in open source GIS, remote sensing. We also offer training and support. We offer sort of three brands of training: one-on-one paid training. We also offer group courses online, and we also offer private group courses. So you can get in touch if you're interested in any of those. We also offer support for open source GIS. This is hourly based support. We don't set up anything like a monthly contract or anything like this. It's kind of like a pay as you go cell phone. Dump a few hours in it if you're going to need them over the course of the year, and we bill in 15-minute intervals. The other thing we do is software development. So our software development division focuses a lot on developing things like WebGIS, these big sort of database-driven applications. All of our designs are mobile first. They're going to work on any device you have. And we can pretty much build anything that's required, especially when it contains a map. The other thing that we focus a lot of effort on, and sort of the topic of this webinar, are our GIS servers. These are fully managed cloud-based servers. We manage backup, support, training, you name it. And a big part of our GIS servers is, in fact, Geoserver. Best way, a lot of you are probably on this already, but the best way to stay in touch with us is through our newsletter. If you haven't signed up, sign up. We do not spam, I promise that. We sort of send a monthly newsletter, and we sometimes send reminders about courses and webinars and things like this. But I think maybe 2 or 3 emails a month or something like this. Next, webinars. We have a busy month. I sort of said yes to a lot of things, and now it's sort of all going to be happening this month. The first presentation is going to be at PostGIS Day, which is organized by Crunchy Data. That's going to be on November 17th, and I'm going to be teaming up with one of my clients to give a presentation on how PostGIS and QGIS can be used in an enterprise environment for the telecom industry. This was a really neat database that we put together, and it's sort of still coming together. We're working out some of the details, but it's heavily integrated into QGIS. So I'm going to be presenting a little bit on that with my my colleague Dane. And then this is the big one of the month. Then we have another QGIS in the Wild, which is a series of talks that we've been doing throughout the year, and we're probably going to continue these. I already have people planned for 2023. We try to do maybe 1 or 2 a month. We had a really great presentation by Bonnie McLean last month. All of these are on our website if you go to lunageo.com/webinar. But Kurt Menke is going to be presenting this month on the 21st. He is the author, of course, of Discover QGIS 3.x. So if you know that book, there's another version, a new version coming out of that book soon, or it's out now, I'm not sure, but Kurt will definitely chat about that. So this is not one to miss, and this is going to be a really interesting story about where QGIS has taken him. He was a US-based consultant and teacher, but he's now moved to Denmark, which is kind of cool. So we're going to hear all about that story. And the last one is the second part to this webinar, is serving vector data with Geoserver on the 30th. This will be a lot of fun. We're going to talk about things like serving PostGIS data through Geoserver. We might touch on shapefiles, even though I hate them. And then we're going to talk about Geopackage and serving Geopackage data through Geoserver. We're going to talk about styling. We're going to talk about security. We're going to talk about all the different aspects of serving vector-based data. Next, we're also going to be teaching a bunch of courses this month and next month, just to close out the calendar year. We're going to be doing our Introduction to QGIS and our Advanced QGIS 1, both in November and December. So if you're looking to sort of dive into this area, these are great courses. We keep them small. I don't like going over 5 people when I do these via Zoom. And they're fun. We spend 4 or 5 hours together going through all of these materials, and then I like to have a private meeting with each attendee the following week, just to go through any questions, any problems you might have. And then through that time, you can always, email me any questions. So we get through somewhere in the neighborhood of like 6 to 8 tutorials, but the rest of the tutorials are yours. You can do them at your leisure. So that's that, lunargeo.com/training if you're interested. And today, what are we going to talk about for the feature presentation? So we're going to talk about sort of our outline is what is Geoserver. We're going to talk about optimizing rasters for Geoserver. I'm also going to turn off my video. Okay, and we are going to talk about serving aerials and DEMs. We consuming raster data from Geoserver. So when we actually serve this up, we're also going to talk about cascading remote WMS, WMTS endpoints, which is something really cool, especially once we get to the next topic, which is, or the next topic over here, which is caching raster layers. And again, before that, we're going to talk also about layer groups in Geoserver, where we can combine vector and raster data sets together and then serve that out as a product. Lastly, or not lastly, but close to the end, we're going to talk about securing raster layers in Geoserver. So the different types of security that you can set up for Geoserver, and a little bit of a live demo just to keep everybody happy. And lastly, of course, a little bit of Q&A. So questions and answers are always open throughout the talk. So please feel free to post your questions. I'll sort of get to them as I get to the end. But if something comes up in the middle and you have a question, just plop it on there and I will try to answer the questions at the end. Okay, big question is, who's this webinar for? Well, I'm sort of targeting it. A lot of the webinars that I give, and I explained this in a few in the past, is that I put together webinars for people who might not be familiar with this technology but want to get into it. I try not to do webinars for, very high level webinars where, we're going to be talking about one very particular aspect of it, and it's very complicated and you need to know a whole bunch of things before you can even approach that very complex subject. I don't like doing webinars like that. I like giving webinars that allow people to sort of get into open source GIS and say, oh, wow, you can do that with this technology. This is great. Let me know more. So if you're new to this, please feel free to, yeah, this is the webinar for you. And I saw somebody just put up their hand. If you have questions, just drop them in the Q&A, and I will be able to get to those at the end of the webinar. Okay, next person I have envisioned for this, my target audience here is people who have never optimized imagery for Geoserver. Some people might have Geoserver running, maybe they share some vector data, maybe they do share imagery, but they sort of want a better recipe. So this is where this comes in. People who use Geoserver but need a recipe for serving rasters. Like, am I doing it right? I hope I'm doing it right. I'm sure there's even aspects of the way I do it that could be improved, but it works. And also people who are looking for cost-effective alternative to proprietary image servers. There are those who are using quite expensive GIS servers to basically produce a WMTS service that they're going to serve out to a bunch of people. So Geoserver really represents a really nice cost-effective solution that doesn't eliminate certain functionality. So what is Geoserver? The big question here. So on the website, you'll get this little snippet of text that says Geoserver is an open source server for sharing geospatial data, designed for interoperability. It publishes data from any major data source using open standards. So open source server, it's actually an OSGeo project. So OSGeo, of course, is the umbrella organization over a number of different open source GIS projects, including QGIS in that group. And this is a server for sharing geospatial data. That first sentence really encapsulates what Geoserver does. It's basically a way of taking a whole bunch of data that you have and serving it out in a number of different formats. I like the interoperability aspect of this. One of the things we're going to see later on in this is we are going to see how we're going to serve something from an Esri server into through Geoserver and out, and you actually cache it within the Geoserver as well. It publishes data from any major spatial data source. So really anything under the sun that you can imagine, you can probably share it within Geoserver. everything from vector to raster data. And the nice thing about this is that it's being served out in open standards. So of course you're looking at your WMS, your WMTS, your WCS, your WFS services. These are all available within Geoserver. So when you first install Geoserver and you get it running, or you buy a server from your friendly neighborhood GIS store, you're going to land on a page like this when you log in. So a couple of things to note. The first thing is you're going to see a summary of all the layers and stores and workspaces within your server. You're also going to have already logged in. So you're going to see that in order to access this screen, you're going to have to log in as an admin. Next, on the right side, you're going to see the endpoints for various web services. There's different service capabilities that you can have access to, that I listed previously, like your WMS and your WMTS services here. Also, different versions. If you have a specific need for WFS version 1.0.0, well, you have access to it here. On the left panel, you're going to see the logs and information. You can access logs and information about the server. You can also change information, the contact information for the server itself from here. Under data, you can manage workspaces, stores, layers, and styles. And we're going to be spending a little bit of time today on this. In the service section, you can do service-specific configuration. So if you want WMS to work a certain way throughout the whole server, this is where you can modify that service. Under the settings section, you can modify the global and raster settings here. And under the tile caching, you can manage tiles, caching location size, and grid sets. And we're going to be taking a look at caching during this webinar, and I'll sort of give you a run through of how this works within Geoserver. Lastly, and perhaps most importantly, is the security settings. This is where you can manage users, groups, authentication methods, data security, and service security. The nice thing about this is that what I'm going to show you today is really the easy stuff. It's the stuff that allows you to load a layer, secure the service, secure the data set, and that's about it. But you can get very, very complex in your configuration of things like authentication methods. One of the things that we often set up at Luna is setting up single sign-on solutions between something like Postgres and Geoserver. So this is where things get a lot more complicated. And lastly, I'll just mention that the address, we normally get this by default, when you install Geoserver on a Tomcat server, it's going to be installed on port 8080. And of course, often when we set this up, or not often, all the time when we set this up, we will set up a reverse proxy. So this could be something like, geo.yourdomain.com, and then that will give you access to the Geoserver. All right. Now let's talk about the big question here. How do we optimize rasters for Geoserver? Now in this talk, I'm going to talk a lot about taking a series of tiles, and we're going to mosaic them together using GDAL, and then we're going to spit that out to the server and then serve that through Geoserver. Now, of course, if you're an organization that's managing data for an entire country and you have these massive data sets, you're probably not going to mosaic them together. But this is a fairly simple method that I've done for, everything from a town up to a county. You can simply mosaic your image together and serve it out as a single massive GeoTIFF. Not always massive, but so I'm going to run through this process with you. So when you're going to optimize rasters for Geoserver, you have a couple of big questions that you have to consider. Are you going to be serving a single mosaic raster or individual tiles? So this is where I don't have a clear-cut answer for you. There's an image mosaicing plugin that you can use within Geoserver if you are going to serve out tiles. But as I said, I'm only going to show you how you can serve this out as a single mosaic raster. What's the type of raster? Is this RGB imagery, RGBI imagery maybe? Is it a DEM? Is it some sort of classified raster? We have to know this. What about compression method? Well, are you okay with lossy compression? Are you okay with the digital number of each pixel that might change a little bit as we compress it? Or do you need lossless compression? This is something that we'll typically need for a classified raster, or something like a digital elevation model where each pixel really means something and you don't want to modify that value. What do we use to optimize imagery? Well, we use GDAL because it does it all. So GDAL stands for the Geospatial Data Abstraction Library. It is the raster processing library and the one that we can use for pretty much everything we need to do. And I would say that it works behind the scenes in most proprietary and open source GIS software. It works on Linux, Mac, and Windows. And I love using it on the command line interface. Why do I use it on the command line interface? Well, if you're running a large process, and I'm sure we've all been in this situation, if you're running something on a desktop application, things grind to a halt as you're processing and you're really not sure, is it running? Did it crash? Is something happening? I like running things on the command line because that little flashing cursor, allows you to see that the process is still running. And I will say, I'll answer a question as it did pop up just now, and it's relevant to this slide, is what about COGS, Cloud-Optimized GeoTIFF? Well, they're very similar to what I'm showing you today, but you can also do that with GDAL. You can output this as a COG, and you can serve that through Geoserver as well. So on Windows, if you need to access the command line, the tool, you can use the OSGeo4W shell, which is nice. If you're using a Mac or Linux machine, you can access it via the terminal if you have GDAL installed. Okay, so we're going to talk about optimizing multi-band orthophoto tiles. The data set that I'm using is a data set from Kamloops, British Columbia. They're orthophotos from 2020. They are available as open data using the link shown here. And don't worry if you don't have time to write this down. I will be sharing this video via YouTube later. So you will be able to access that that way. I'll put a couple of links on the YouTube video once I post it. The sample I'm using are 35 tiles, and they each measure about 1.2 kilometers by 1.5. This is a 10 centimeter spatial resolution product with 3 spectral bands. So if I'm going to just show you quickly what we're dealing with here. So this is pretty much what we're dealing with here, is where we have these individual tiles, and you can see they're individual tiles that we can turn on and off. And it's a very, very high spatial resolution product, down to 10 centimeters. And do let me know if you didn't just see QGIS there, because I was just swapping virtual desktops here. All right, so the first command that we do is I'll typically download all of these tiles. I wrote a script in order to download every single tile. And I will use a command called Gdal build VRT. So build VRT, Gdal build VRT will basically build a virtual raster. So all it really is a text document that says, okay, we're adding all these bunch of images, and we're going to mosaic it into a single one. We're not going to load the VRT or do anything with it. It's just a very easy way of mosaicing together. We're also going to add the add alpha flag to this in order to add an alpha band if one is not already present within the data set. So the last part of this command is basically saying that all GeoTIFF, so all files with a .tif ending, we want to merge them into this VRT. So the thing about this is that you want to make sure that the only thing within the directory when you run this are the TIFFs that you want to merge. So if you've had a little bit of trial and error and you've created one and created another one and, oh, that didn't look right, I'm going to try another one, don't run this command in that folder. Make sure that you move or delete those other images and that you only have the original tiles when you run this command. Next, this is where it gets a little more complicated. So what we're going to do is we're going to use a tool called Gdal Translate. And we're going to specify the bands. And some might say, well, why are you specifying all the bands? Well, sometimes there's actually a 4-band raster. Sometimes you might have that near infrared band in the data. So what I find is, even if it's 3-band data, I will still specify all 3 bands. It's not the end of the world to add this. And I'll also add the flag mask 4, because remember, we added an alpha band to our VRT. So we want to make sure that we have that transparency layer. Now, this is important for this data set, especially because if you look back to when we're looking at it in QGIS, I'll just zoom out. We have areas like this. It's not perfectly square. So if we didn't add this alpha band, all this area right here would end up being black. But right now, when I can't identify that because I don't know which tile it is, but all of this would be black if we didn't have this. So now we have it as transparent. So if we load this over something else like you know, a base map, is that we're still going to be able to see through this area. Okay. Back to the fun. Okay, so next thing, what about block size? So we're going to be building internal tiles with this. So we've already merged everything together with a VRT, and now we're going to build internal X and Y tiles. Typical sizes will be 256 or 512. I have 512 on here, but I often use 256. I use a smaller tile, and you're going to see later on when we get to building the grid sets in Geoserver why I like to use the 256. We're going to have the other flag that says tiled yes. And then this is a big one. If you're loading a massive amount of imagery, and for this, I'm using only, like, what was it, 36 or something, or tiles. I actually did it for the entire Kamloops aerial photos, which is like hundreds of individual tiles. And it ended up being 36 gigabytes. Now, the regular TIFF has a max of like 2 gigs that it can be. But since we're going to be bringing this up to like 36 gigs in a single file, we need to use the big TIFF yes flag here in order to exceed that ceiling. This is something I've started to do a lot when I run this command, is just to basically define the spatial reference system for the output. And that's what this flag does. I've had problems in the past with funky imagery that has weird metadata attached to it. And I've had a lot of problems with imagery that have come from different drone software. So I find that if I know what the EPSG number should be for the output, I will just put it in here to make sure that the output has it. It's not the end of the world if you end up with an image that doesn't have that defined, because you can edit those metadata within the GeoTIFF and add that to it. I'm going to use the YCBCR color model, and I'm going to be compressing this. So I will be using a lossy compression method. I'll be using JPEG to create a nice, neat little optimized image. Now, if you loaded this, it would still sort of load, but if you're loading a very large image, even at this point, I would say don't load this in QGIS just yet, because it's still going to be quite slow because we haven't yet created overviews. So the GDEL command in GDAL is the one that you're going to use to create these overviews. Overviews, pyramids, whatever you want to call them. And one of the big important flags that we're going to add here is the config interleave overview. There's 2 ways of building overviews with rasters. They can be external or they can be internal. We want these to be internal so that we have a single GeoTIFF that has everything in it. It has those internal tiles that we built, but it also has the pyramids or the overviews that we've built inside the file itself, not in some sort of external overview file. And again, these are going to be compressed. We're going to be using a compression method and the same JPEG compression method. And then I list a whole bunch of different levels that I'm going to be producing these at. And I do quite a few when I produce these. And what we end up with is obviously the optimized imagery. So when we run this command, we end up with, I'm going to turn this one off. We end up with this single file that mosaics everything all together. Now, I will say, I've seen other file formats being used. If this is running off my local machine, of course, if your imagery does not act this fast when you're zooming in and out, you're doing something wrong. Even if it's being run on a local server and you just have a file server where there's either something wrong with your network or your imagery is not optimized correctly. You can do this to even just keep imagery sitting on your local share and have people access it that way. But of course, you don't have all the same capabilities that you have with Geoserver, and you can't share it outside of your network as easily. So yeah, fast, quick, and it has the same 10 centimeter spatial resolution. Everything's the same, except we've built all of these wonderful capabilities into the file. So the next thing we're going to be doing is we're going to be tapping into the Ontario Digital Terrain Model. It's a LiDAR derived product, and it's available here in this very long URL. And we're going to be doing a couple of different things. One, we're going to produce a hillshade. We produced a hillshade, and we're going to create some really bad looking contour lines that I did. I tried to clean up a bunch of them, but I didn't do this as well as I could have. So we're going to be using these 10-meter contour lines and apply them to here. And we're going to eventually serve this out as a group layer within Geoserver, and I'm going to show you how we're going to do that. So when we're building the DEM, I didn't add the build the alpha band to this with the GDAL build VRT. I just sort of grabbed all the IMG files that were in the folder and produced, or the ones that I selected that I'm going to use, and I built a mosaic. Again, I used block size, X and Y is 512, 256 could have been better, but this was a small image, so I wasn't too concerned. I still have the big TIFF yes flag on there. I will typically just put that on because if I know that there's a possibility that it might go over that 2 gigs, it's really annoying when you're halfway through processing something only to realize that you've hit that max. So I plop that in there, and again, I plop out the the output spatial reference system as EPSG 26917, which is UTM 17 North. I'm using a lossless compression method, LZW, and the last part we see that we're inserting the mosaic VRT as our input, and our output is going to be this output.tiff. Now for the hillshade, I did something different, and I just want to show you. I used deflate, so another compression method. Really doesn't matter what you do for hillshade. Hillshade is just a pretty picture. You could have used JPEG compression on it, would have been fine. I have it as tiled. I'm building the same types of block sizes for each, and I'm outputting with the same coordinate reference system, and I'm outputting this hillshade.tiff. So really, the output from this is my input for here, if that makes sense. So I'm going to build the overviews, and same thing as we saw with the aerials, except again with the compression method, I'm using the LZW, and we can't use anything. If you try to take the build the different color model using the color model that I used for the orthos, you can't really use that for single band rasters, of course. So we strip that out of the command, of course, when we're running this. And same thing for hillshade, not much difference. We're using pretty much the same command here to build the overviews. Okay, this is sort of goes without saying, but it might be helpful. Depending on how you have your server set up, once you process this stuff locally, you sort of want to put it onto your server. If you have, direct access to that server and you can just copy the files, do it. If you need to use secured FTP or even just FTP to access your server, do that. Oftentimes there isn't an easy way of uploading imagery directly into Geoserver. There's nothing through the web interface where you can say, take this image and upload it. Typically because these images might be quite large, so you might want to use another piece of software. I've used both these, Bitfiles and FileZilla. Lately, I've been using FileZilla. It works really nicely on Linux, and I'm happy with it. But sometimes I just do it on the command line too, and I'll just use SCP just to transfer it, my files to my servers. Okay, now let's get into the fun stuff. So now we're going to be serving ortho photos and DEMs. All right, so we are going, and just a reminder to anybody who's raising their hands, if you can just drop your questions in the Q&A, I will definitely get to your questions by the end of this. Thank you. So step one, when we log into Geoserver, we can do things like create a workspace. I'm just going to log back in. that. All right, so we're going to create a new workspace for imagery. It's kind of optional. Sometimes I like to create a new workspace, but there's two things you can sort of do with this. If I am going to create a workspace, you have a name, you have to put a URI in, but you can also have this be the default workspace so that any layers you share will automatically be put into this workspace. You can also have these be isolated workspaces. Isolated workspaces are nice because they're completely separate from your other layers. All right, so I said that already. So what we're going to be doing is the step 2 is we're going to create a GeoTIFF data store. When you click on stores here, you then click on add a GeoTIFF data store. And for this, there's a couple of pieces of information that we want to put in. We want to put the name title to the layer. We want to check that the spatial reference system is correctly identified. And we want to check that the B-box values are correct. And we want to save this layer. So we're going to be creating our layer from our store. And next, we're going to be able to preview our layer. So quite easily, we're going to be able to go in and check out our preview. So I have a bunch of these already created. So I can come in now and I have this new aerial that I created. And this layer is now being served on Geoserver. So this was optimized using the commands that I just showed you. And now this is being served as a WMS via Geoserver. Okay, next thing. What about, I also did the exact same thing when I was serving out the DEM and the hillshade, and you can see those as well too. So we can look at the hillshade right here, and this will serve out quite nicely. We have access to the hillshade. Likewise, we can go out and look at just the DEM, and you'll notice that I have a little style on here. I'll sort of get to that in a sec. For DEMs, we also want to upload the style. So how do we do that? What's really nice in QGIS is you can just export the SLD for a DEM. So once you style your DEM using whatever system you want, you can then use the style from Geoserver and load that into the style from QGIS and load that into Geoserver and save that as a new style. So once Geoserver has that new style, then all you have to do is you have to go back into publishing on your layer. You got to edit the layer, click on the publishing tab, scroll down to the WMS settings and change the default style to the DEM style. So in this case, I created a new one called contour style or something, and I saved and I previewed. So now we're actually seeing the same style that we see that we created in QGIS. And you'll see this. So the same style that you're going to see will exist in both. Now, it's a little manual in that you have to copy the SLD files back and forth so that in QGIS, if you change something, you then have to go into Geoserver and update that style. But it's fairly simple. Now, another nice thing that I've been doing recently is cascading WMS and WMTS endpoints through Geoserver. This is really easy, a nice thing to do, but there's a couple of gotchas that you have to be aware of. The Southwestern Ontario Orthophotography Project, nicknamed SWOOP, 2015 aerials are all available online as a WMTS server being served out through an Esri server. But this is the scenario that I'm constantly in. If somebody has a bunch of external services that they have access to, and they have a bunch of internal staff who are accessing those, they need to set up this connection on every single machine. The nice way, the solution that we can offer through Geoserver is we can cascade those remote services. Excuse me. Which basically means that we can take the remote service, we can serve it through our Geoserver, and then spit it out to the individual clients. What this means, we'll get to it, is that we're then able to create sort of one server that has everything in it. It's a very simple process. You go to add a new store and you select Cascade WMTS, which is an option. So if I was going into the new store here, you're going to see at the bottom, if I click add new store, this other data sources, this WMTS Cascade or remote web map tile service. And then we're going to give it a name. We're going to name the data store, and we're going to paste the WMTS URL onto the URL line, take away the password, take away everything, because this is a wide open WMTS server. But if it does have credentials that you need to use, of course, enter those in there. Press save and publish. Now, when you press save, you're going to be presented with this option, which is Swoop 2015 TBK. You do have to press this publish button in order to actually publish the layer. Now, in the edit layer screen, press save. There's nothing else you need to do. And at this point, you can preview it, and you're going to see that you now have access to the entire bunch of imagery through Swoop 2015 as a cascaded. Oops, sorry. Well, that's weird. Don't know. All right, so we have the cascaded service can be also cached locally, which is really nice. So you can cache this layer and store a version of it sort of on your own server. The spatial reference system is restricted by the source WMTS, so this is just something to be aware. So if it is only published in 3857, you can only cascade and cache it in this same SRS. Bottom line, what's really nice about this is that your GeoServer can be sort of the single source of truth for internal and external imagery. You can really have one server to rule them all. The nice thing about this is that if you're then creating QGIS projects using cascaded services, if the service goes down, you don't have to, or the service changes endpoint. That's a really good scenario that I've encountered a lot. So all of a sudden, they're still serving it, but they're serving it with a complete different endpoint. Now all you have to do is go into your GeoServer and change that endpoint URL, as opposed to logging into the 25 different computers for everybody on your staff who are accessing this stuff and getting them to all change the URL. So it's just a lot more efficient way of doing it. And the other thing that I really like about this is that you're naming the layer consistently. So if you are creating a project that calls this external service from GeoServer that's called Swoop 2015, whether it's Swoop 2015 coming from this source or that source or another source, or your own local source, let's say one day they release Swoop 2015 and you're able to actually download all of this imagery and then serve it yourself as opposed to relying on an external WMTS service, you can then just mosaic the whole thing, serve it out, call it Swoop 2015. It's not going to impact any of the projects that you've used this for because they're all still going to be referring to the same layer name. All right, layer groups in GeoServer. This is another thing that's kind of nice. Think base map. So we will often use, you might want to create a base map. You might have a number of different layers, roads, parcels, whatever you want. You want to sort of combine these and serve them out as some sort of base map. Well, you can do that with GeoServer. You can do that with layers groups. This is essentially what we want to create. We want to create a hill shade. We want to drape a DEM on it and make it like 50% transparent. And then we want to put these really terrible contour lines that I've made in a pinch and throw those on top. And we're going to call this our elevation layer. So it can be used for cartographic purposes. I wouldn't do any type of scientific analysis on this layer, but this is a nice one to serve out if you just want to have this on your map. How do we go about this? Well, we go into layer group here and we simply add a layer group. First, we create a new group layer and we, of course, name it something. And we load the layers into the group at the bottom. Note that layer 1, just so you know, layer 1 is the bottom, layer 3 is the top. So in here, we see that our hill shade is at the bottom, followed by our elevation model, our LiDAR elevation model, and then on the top, we have our contour lines. And then we're going to save and preview that layer. And when we do that, we see that it looks pretty similar to the one that's in QGIS, right? We have the same style that's applied to the DEM with that transparency. We can see the hill shade underneath, and then we have our contour lines. I didn't really talk about how I share these contour lines. These are coming from a PostGIS database. I could edit these. I could do anything I want. I could put a big line through here in PostGIS, and then they would appear with it on the WMS service immediately. So if we go into quickly, And then this is our service that we're serving out. So we're really, what you're really looking at right now is you're looking at 3 different layers being served out at the same time, overlaid on top of each other. This is a handy little tool, especially if you have staff that you might not want to give them direct access to your entire database. You want to say, listen, I have a bunch of base map data. You can access it through the WMTS service or WMS service, however you're going to serve it, and then you'll be able to load these up. The other thing too is it allows you to kind of like centralize your styles, right? It allows you to say, okay, well, everything is now, contour lines are always going to be this sort of shade of orange, and nobody can change this. So any maps being produced in your organization will look exactly like this. Okay. This is a big subject. We're doing well for time. So caching raster layers using GeoWebCache. GeoWebCache has now been, it used to sort of be external to Geoserver, and now it's integrated within Geoserver. So this is a way that we're able to actually cache layers. So that's just like storing a smaller version of the data set or portions of the data set, as we're going to do, on your local server, just to speed up the process so it doesn't constantly have to go back and query the original data set. So caching rasters, we're going to talk first steps really, and this is the section in Geoserver that we're going to be working with right now. We're going to talk first about the caching defaults right here. So you want to enable and set, the quota is what we're going to talk about first. So the first thing you really want to do is you want to enable and set the disk quota in the storage location. This can get a little more complicated than simply just stating the maximum. In this scenario, I just set it to 25 gigabytes. But you can be generous. If you have a lot of space on your server and you want to dedicate 100 gigs to cache, you can do that. I have it set to be using something called the in-process database, but you can actually have something like, you can have an external blob store. So you can have a directory on your server that's just for cache, and you can refer to that and save everything into there. That's a little more advanced than what I want to talk about today, because there's permission issues and things like this that come into play where you have to give Geoserver permission to actually write within those directories. So that's for another time. We're going to talk about editing the grid set next. So a grid set, when we set this up, we have a number of different grid sets. You want a grid set set up directly for your data that has, again, the tile dimensions. You can see here we have 256 and 512. We want to have one set up for the tile dimensions that we have within our raster. So those internal tiles that we created. You'll get a lot faster load, I believe, if you're using the same tile dimensions for both your caching as well as how you optimize the imagery at first. So you want to build a grid data set for the desired spatial reference system. You want to set the tile size, as I said, to match your optimized internal tiles if possible. And I typically add anywhere from 15 to 22 different zoom levels. So that what that means is that we're going to be creating cache for every different zoom level that we define. Next thing we want to do is we want to go into the layer and we want to actually apply this grid set to it. We want to select the image formats for the service first. So how do we actually want to serve this out? So in the edit layer section, we can go into tile caching here, and we're looking at the Kamloops aerial photo that I have on here. And we can select a number of different formats that we're going to serve these out. The difference mainly here is, are we going to be serving this out as JPEGs, or are we going to serve this out as PNGs? That's pretty much the decision that you have to make. And it really comes down to transparency in most cases. A JPEG does not allow you to serve anything out as a transparent layer, whereas PNG does. So think of the contour lines. We have our contour lines on top of other layers. We want them to have transparency so that we see stuff between. If we don't, if we just serve it out as a JPEG, all you're going to see is contour lines in white. So you would not be able to see something like your OSM layer underneath or anything else. But for imagery, in this case, for the Kamloops aerial, we're going to serve that out as a JPEG. So note, you also want to remove the default grid sets. You don't want to serve this out in all the default grid sets. You want to really control, or else when somebody connects to your WMTS service, they're going to see a big list of layers, and it's going to be a little overwhelming to pick out the one they want. So I always remove the default grid sets, and I'll add just EPSG 3157, which is BC Albers. So this, and that's actually the coordinate reference system of the data source itself. Now, of course, if you're going to serve this out to the web, you're going to want to have this in Web Mercator, so 3857. So you're going to want to create a grid set for that as well. But if you're just serving this locally into QGIS, there's no real reason to create a grid set. You can create 3857 or whatever you want, but when I'm serving just to QGIS, and I know that that's the only place it's going to be used is within QGIS, and they're going to, all their projects are set up in 3157, I will actually cache for that that SRS. Save. That's the important part. Save. Okay, so caching rasters. Now, the next thing is that we want to actually look at our tile layers. This is kind of fun because we can do a bunch of things here. So if we click on tile layers, we can monitor the disk usage. So remember, we set that limit for our tile caching, right? I had it set to 25 gigs. You can actually pre-generate cache by seeding layers here. So this is the seed button here. You can go in and pre-generate some of the tiles. Now, keep in mind, if you have a massive imagery, 256 by 256 tiles, and you want to generate cache for every single one, this is going to be a fairly long process. You can also do things like empty cache. Why in the world would you ever want to empty the cache? Well, if you ever change something, let's say you change the style for, this is a really good example. If you change the style for something that is a vector data set, so something like the cache, then what you want to do is you want to come in here. Let's say it was orange and now it's purple. Everybody who's accessing the data and accessing the cache data isn't still going to see it as orange until you dump the cache. So what you want to do is you want to come in here and you want to empty the cache, and then it will regenerate the cache as you use it. One of the neat things about this is, so if I go into tile layers here, I see the amount. So I'm just going to give you a little demo of how this kind of works. I'll actually hold on that. I'm going to show you this once we connect to it, because I want to talk about securing rasters first. Let's talk about securing, and then I'll give you a full demo on just how we access these layers. Okay, security in Geoserver is a fairly complex thing, but rightfully so, right? This is giving users access to your data and users access to possibly a lot more into your database. If you have layers in your database, you might have actually connected to your database using a user that has writability. So if you haven't controlled who can have writability on those data sets, well, if you open this up to the public, then the public can edit your data sets directly into your database. So this is where a lot of thought has to go into how we put this up. Okay, user management is the first thing we have to think of. And when there's three sort of terms that we need to be familiar with here. Users, these are our actual login users. And then we have roles. Specific roles for different types of users: admin, read-only, editors, and users can be part of roles, or roles can be assigned to different users. And then we have this concept of groups, where a group is going to be a group of roles. So users are members of roles, or roles are applied to different users, and then those roles can be part of a different group. So that here we can get quite granular in how we assign permissions within the Geoserver. In this example, we're just looking at data security. So we can also secure data at the data level. So rules can specify things like the workspace that is able to access the data, or what workspace you're going to be accessing, what layers are grouped within that workspace you're going to be accessing. The access mode, is it just going to be read, write, or full admin privileges? And as well, the roles that can be accessed to a specific data. And you can see here that we're not granting, for data security, we're not granting it to the individual users. Those individual users are part of a role, and then we're going to grant access via the role. So very similar how we would do this in any type of server situation when we're managing a number of users. The next thing is the service level security, and this is where it gets kind of tricky. Because we're giving people access to the data, sure, but we can also lock things down at the service level. So when I say service level, I of course mean WMS, WFS, and so on. So you can lock access. So you can turn services on or off for different types of users. And the example given here would be admin users have access to everything. That star.star means they have access to every service and every aspect of that service. Whereas the people who are members only of the staff read role only have access to WMS services, but every part of that service. So they can get capabilities, get maps, whatever they need to do. They're able to fully access that. Now, that doesn't mean they have access to all your data, because you might have set up data security on different workspaces. So they might only have WMS access to a certain workspace within your GeoServer. So you can see how this can get quite complicated. And it's something that we really have to think through as we open up these services. So let's talk about consuming raster data from GeoServer. In this example, I'm just going to show you how we connect via QGIS, and we're able to access all of these services. The two services I'm showing you today are the WMTS service, which is the tile service, which is the cached service, and WMS. So we can get the WMS or the WMTS endpoints. You can simply come here, and as you're on your GeoServer main page, you can just right-click, copy link address, boom, you have it, and you're ready to go. All right, so the WMTS for me is preferred a lot for imagery. Because we're building that grid set and we're specifying the coordinate reference system, we're specifying the tile size, we're doing a lot of different things. That gives us a lot of control over how our users are actually going to use it. And this is why WMTS is a little bit better than using WMS for this purpose. The difference with WMS is that the user could actually specify the tile size, at least in QGIS's interface, right? So they can specify the coordinate reference system. So it puts a lot more pressure on the service to meet the demand of the request. Whereas with the tiled service, WMTS, you're getting what the server is producing. So in QGIS, you're going to create a new WMS WMTS connection. You're going to name the connection, and you're going to use configurations instead of basic authentication. If you're not using configurations when you're setting up your user connections in QGIS, you should be mindful of this, because if you do save it just with basic authentication, your credentials are being saved to your QGIS project. So if you were going to one day just share a QGIS project with somebody else, that's here, I'll send it to you. In that project, all of your credentials are saved in plain text. But when you use configurations, all you're saving is an ID that refers to your configuration. So it does not save your username and password for the remote service. So it's a much better way, and something that everybody should sort of get in the habit of doing if they're connecting to these remote secure connections. So the last thing you have to do is enter your endpoint URL. So that's the URL that we got from GeoServer. You're going to drop that on the URL line right here, and we are good to go, and you should have a connection to that server. And depending whether you're dropping whether you're dropping a WMS or the WMTS connection, that will dictate how the service will work once you connect within QGIS. So let me show you how this works. So we already know we have all these layers that we've connected to. So what we're going to do now is we're going to connect to them. I've already created my connections, of course. And I've created a WMS connection. Now, I showed you that we can connect with WMS, and we can load things like the Kamloops 2020 data. But here, this is where I was saying we can specify many different things here. We can specify, do we want it as a PNG? Do we want it as a JPEG? What coordinate reference system do we want this to come in? I actually have to go in and specify. For most of us in the room, probably this wouldn't be a problem. And I know, I do this with WMS connections all the time. But in an enterprise environment where you have people of various skill, shall we say, sometimes just doing something like that is a little bit much for them. But this loads. So now we're loading our WMS service, and this is loading from one of our cloud-based servers. So it's not even local. And I have a fairly good internet connection. You know, not the fastest in the world, but I can pretty much do what I need to do. But you're noticing that it's being loaded as sort of like a single tile, right? It comes in. The other thing we can do is, if I close this down, what I prefer, is I've created the WMTS connection. Now, when I do the WMTS connection, this pops up in front of you. And this comes back to when we cached the layers. So let's look at the Kamloops, the RGB, sorry, imagery that we have here. It's only being shared out as JPEG. So I'm not even giving you the option of getting it as a PNG or getting it as a JPEG. I have the layer, it's a raster, and I have the tile set. So automatically it's going to come out in EPSG 3157. So I can add this to the map. Now it is right here. I just don't have the extent set up properly. So as we load this layer, you're going to see it's quite fast to load now, right? Because right now we're loading these from cache. So I've already been tinkering around with this and it loaded up pretty much all of the imagery. Now I want you to notice this. I'm going to show you, going back to our tile layers. This is the layer, this is the layer right here that we're looking at. Right now, the disk usage is at 64, around 64 meg, so not much, right? But if I go back to QGIS and I start loading into this new layer, so it's a little bit slower as we start, it's thinking, it's processing, but it's creating a cache as we go. So if I refresh this page, you can see now we're up to 69. And again, if I start moving around a little bit more and loading in and zooming in, it's loading these new tiles. And as I come back here, we're at 69. Now we're at 72. So we're loading these tiles as we go. This is really handy when you have a large bunch of imagery that you're going to be serving on. You see how fast this is loading now, because it doesn't have to make that call back to the original data set. It's just Geoserver spitting this out to you. So even on a web map application, this is a lot faster to use. But if this is an area, let's say that you're doing a lot of work in, and you're always coming back here, you're always going to have this cache build. So it's going to be just a lot faster to work on. If conversely, you know, the area up here is somewhere that, you know, you don't go that often, there's not a lot of looking around here, you can see this is taking a little longer to load, and they're loading with the tile slowly. But now that it's loaded, if I come back in, you see how fast it is now to load. It doesn't do that process again, because, again, focus on the 72 here. Now we're up to 86 megs of tiled cache. So the same thing works for our other data sets that we have. And one of the reasons why I like the WMTS is, as we go in, we can look at the Ontario one that we created. This is the Ontario DEM. So we can load the DEM. I gave two options here. I gave the JPEG. I gave two coordinate reference systems for this. I have it in 3857 if we're planning on sharing this on the web. And I have it as UTM 17 North if you're using it within QGIS and going to be combining it with a bunch of other projects. So I can add this, close, and now we have our DEM loaded on the map. I can also load, I can close this down. I can go back in and I can load our elevation. I have it again, I have it as 3857 and as 17 North. This is our group layer. And now our group layer is loaded within QGIS. So super easy. Now, what if I wanted to load just the contour layers on top of like an open street map? Okay, so let's add open street map. We're doing this all in 26917, so we're making OpenStreetMap work a little bit more, QGIS work a little bit more. So now what we want to do is add just those contour lines that we created. So I'm going to add them. I'm going to add the one that's EPSG 26917, and I'm going to add it's a PNG. So that allows you to have transparency, right? So now we have our imagery loaded here with our contours. Let's go in. I'm just going to do something that I like to do. We're going to turn this into colorize the OSM. So it's just like a grayscale. So now we can see the contour lines that we just created on the map. And this is being loaded not as a vector data set. These are individual tiles being loaded on our map. So this is, again, is a nice way of serving out data to users. So if you don't want to give them direct access to the database, you can give them access to this. And by using a WMTS service, this allows you to really specify all aspects of the connection. So the last thing I want to show you in terms of is just security. So I'm going to break things now, which every good webinar ends with you breaking something. Right now, you know that when we set up the security for here, we had everybody can read if they're connected as an admin. I'm using admin credentials in QGIS when I connect to this. So again, if I try to connect without, you're going to see what happens. So what we're going to do here is in our connection, I'm going to edit it. And instead of having the Geoserver connection, I'm going to set it to no authentication and press OK. You know, ta-da, it shows you a lot. It says you need to enter credentials in order to access this service. So I actually have to go in and apply my credentials and in order to gain access to this service. Right. Now I have access again. So that's the most basic of security settings, probably the most basic of optimizing imagery that you can do with this platform. So I hope that was helpful, at least to sort of get people into this. I will do a little song and dance and just tell you that one thing we're doing from now until the end of December is that if you sort of want to have your own GeoServer and not go through the mess of having to set it up, as I said, we offer GIS servers. We can configure them from top to bottom and set this up. But I like getting people to actually use this technology. So what we're doing is we're cutting our price in half for 3 months for every new client. So if you come on and you say, you know what, I want to give this a go, even just for 1 month, I want to try GeoServer out. It's quite a good value because you're going to be able to get PostGIS, GeoServer, GeoNode, really whatever you want in terms of open source GIS. I set up a free implementation plan for you. So this is a nice meeting where we can talk about what kind of data do you have? How do you want to serve it out to a server? And we go through, I might not do all the work for you right away, but we can sort of put together a plan as to what this would look like if you actually use this in production. I also do a free 2-hour training session. This gives you a really good idea on how to use PostGIS within QGIS, how you set up layers, how you upload layers, how you set up Geoserver, how you set up the security for both, and permissions within the database is huge. The big thing is that this is not a sort of, I'm going to sign you up for 3 months and then lock you down for the next 10 years. This is really just an opportunity for you to try it. If you try it for a few months and say, you know what, this is great. Now I know I'm better informed when it comes to open source GIS. This is your opportunity to do that. So use the promo code server 2022. And again, this does, we're not extending this past the end of the year. So this does expire on December 31st. Go to lunageo.com/servers or send me an email or a Twitter message or anything you want. All right, questions now. I will get to. Bernie's asked a few. Drop them in the Q&A if you guys have any. If you have some that you have afterwards and you think, you know what, I should have asked that, send me an email, cpatterson@lunageo.com. I will be happy to answer anything. We already talked about COGS. Oh, New Brunswick data. Thanks, Bernie. I'm going to save that. That's really helpful. And how do you upload images using SCP? Well, SCP is just a command line program, so you can just sort of upload images to the server, send servers. And then, what is the normal price of a GIS server? Just reading the one that just popped out now. How is that priced depending on the amount of data, number of users? If you, Nelly, if you head over to our website, you can see we have sort of 3 pricing tiers set up. Of course, we can develop anything beyond that. If you wanted some, you know, if you want a massive forest of GeoServers, you know, we can set up something on that enterprise scale. But we have 3 prices set up on the server. So one of the things that I try to do as much as possible with our company is be as transparent as possible with this. I think the spirit of open source GIS is transparency. So as I help people navigate this world and set up solutions for them. I try to be as transparent with pricing as possible. So it's all in black and white on our website. There's no tricks or gimmicks. Can you import scale levels? Like, yeah, the scales levels are pretty much referring to the same type of thing, right? So as you zoom in and out on like a leaflet map, or if it's tiled, or something like OpenStreetMap, or sorry, Open Layers is what I meant, it will call those same different tiles at different layers. Okay, realize I've gone 5 minutes over. Thanks everyone for your time and for attending. This is fun, and do come to our next one, which is going to be on vector data, where I will dive into all the wonders of serving vector data with Geoserver, which should be a lot of fun. So hope to see you there. Thanks a lot for all the questions. And again, anything else, message me. You know where I am. Take care. Thank you.